Hello and welcome to D Creations Resources. We have been looking at different topics from mathematics, especially linear algebra. And in today's episode, we are going to solve a system of equations by Gaussian elimination method. Now, a system of equations has been given to you here. You can see x minus 3y minus 2z is equal to 6, 2x minus 4y minus 3z is equal to 8. Minus 3x plus 6y plus 8z is equal to minus 5. Now how will we solve it? We are going to make use of row echelon form. And if you are able to recall, long back we had learned what basically is row echelon form of a matrix. We had seen what the characteristics should be. Then we had converted a matrix to its row echelon form by using row operations, basically Gaussian elimination. And then we had also seen how this is related to the application of solving a system of equations. So we had taken a system of equations and then used the row operations and found the answer. Now this is more of a practice problem to apply whatever you've already learned. If you've forgotten it, you can go back and visit it. So here we have this system of equations. Now our first task is to write down the matrices. So the first matrix is going to consist of all the entries which are the coefficients here for x or y or z, etc. So as you can see here, first equation, coefficient of x is 1, coefficient of y is minus 3 and coefficient of z is minus 2. So 1 minus 3 minus 2. Similarly, for the second equation, 2 minus 4 minus 3, you can see it coming here. And for the third equation, minus 3, 6, 8, minus 3, 6, 8. Now, basically, we are rewriting these equations as this matrix into the matrix consisting of x, y, z. And if you multiply the matrices, the answer that you would get is the right hand side here, 6, 8, minus 5. In order to solve it, we are going to augment it. That means we will take this inside here to the initial matrix. So we have this total matrix, 1 minus 3 minus 2, 6. 2 minus 4 minus 3, 8. Minus 3, 6, 8, minus 5. Now we are going to perform row operations on it. If you recall, we want all the entries here to become 0. So in order to do that, we will perform row operation which will lead this 2 to become 0 and minus 3 to become 0. Now if this 2 has to become 0, what will you have to do? You will have to subtract 2 from it. And you can see in the row 1 you have this element 1 already. So if you multiply the first row by 2, which will give you 2, and if you subtract it from row 2, it will give you 0. So R2 minus 2R1, where R2 is the second row, R1 is the first row. This is the first operation. And simultaneously we can perform one more operation because we also want this entry of minus 3 to become 0. So in order to do that, minus 3, you have to add plus 3, and you can see that here you have 1, so 3 into 1. So R3 plus 3 into R1. R3 is row 3, R1 is row 1. So let us simultaneously do these operations. Now please understand that there is going to be no change in the first row because nothing is being added or subtracted to that. So that we can write as it is. Now in the second row, well, whatever operation we are doing, it has to be there for all the entries. So 2 will become 0 because it's 2 minus 2 is 0. Here minus 3 into 2 is minus 6. So if you subtract that from minus 4 plus 6, which will give you 2. Then minus 2 into minus 2 is 4. So minus 3 plus 4 will give you 1. And minus 2 into 6 is minus 12. So 8 minus 12 will give you minus 4. Similarly, for this particular operation, R3 plus 3 R1, minus 3 plus 3 will give you 0. Then 6 and minus 9 will give you minus 3. 8 minus 6 will give you 2. And finally minus 5 and here you have 18. So minus 5 plus 18 will give you 13. So we have come to this matrix. But still, we have not got the row echelon form because even this number has to become 0. How will that become 0? If you multiply row 2 by 3 by 2, so here 2 into 3 by 2 will give you plus 3, and if you then add it to row 3, minus 3 plus 3 will give you 0. So here anyway the first entry was 0 itself, so we don't have to worry about it. So we get 0 at this position as well. And for the third case, 3 by 2 plus 2, so that will give you 7 by 2. And finally you will have here minus 4 into 3 by 2, which is basically minus 6, and 13 minus 6 is 7. So you are left with this matrix. You have reached the row echelon form where you will have all the zeros below a leading entry to be 0, and the leading entry in this row has to be to the right of the one above it. So everywhere that is happening. So 2 is to the right of 1, 7 by 2 is to the right of 1 and 2, and so on. Now you have seen that our life has become easier. Now if you go back to this kind of a form, then here you will have 0, here you will have 0, and you will have 7 by 2. This xyz is still here, and you will have 7 here. So this last equation just becomes 7 by 2 z is equal to 7. So answer is oral, z has to be 2. So we've already got one of the variables as 2, and once we get it, then you just have to back substitute it. So for example, when the value of z is 2, you can back substitute and get the value of y to be minus 3. So for example, here you can do it also. So 2 and this is minus 4. So this is going to give you minus 6 on the other side. So 2y plus z, that is how it was. And instead of z you will put 2 here, which will go on the other side. This will become minus 6. So 2y is equal to minus 6. So y is equal to minus 3. And then if you substitute both these values in the first equation, you will get the value of x to be 1. So the answer is x is 1, y is equal to minus 3, z is equal to 2. In these kind of questions, you can always just back substitute and check whether you've got the real or correct answer. So this is an easy method to solve this system of equations where we made use of the concept of row echelon form. So you can practice this problem. You can also practice with the earlier problem that was shown in the earlier episodes. And then on your own also you can take a system of equations and try to see or try to solve them as well. So we'll stop here. Thank you.